Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Intel. We have Scott Misage. He is the general manager of the Intel Omni-Path business unit. So, Scott, welcome to the show today.
Thanks, Rich. Pleasure to be here.
Well, thanks, Scott. I guess I understand that I might be one of your first media interviews, so thanks for that opportunity. It's great to talk to you again.
Yes, I'm at a new company. You knew me well from my past life at Hewlett-Packard, but I'm really pleased to be here at Intel, where I'm managing the Omni-Path division.
Yeah, and I think you've landed at a great spot, Scott. You know, I've been reading more and more about Intel Omni-Path, and looking forward to ISC, where I'm sure you'll have much to tell us about there. But tell you what, Scott, I brought your slides up. Why don't we start with that, and then we'll do a Q&A at the end.
Absolutely. Sounds like a plan. Okay, so let's get started. So let me tell you at first what I'm going to talk to you about today. So I'm going to give you a little bit of a view to our portfolio. I'll talk to you about how we're doing for performance, right? Very key asset of our value proposition for our Omni-Path product line. I'm going to talk to you a little bit about how we're doing in the market, and then as you touched upon, we'll give you a little bit of a preview of what to expect at the upcoming International Supercomputing Conference in Frankfurt. Okay, so let's cover a little bit about the Omni-Path portfolio. Let me begin by talking to you at a very high level, Rich, about where Omni-Path fits into the larger picture at Intel. So Intel has something we call the virtuous cycle of growth, okay, and that is at a very high level the depiction of our strategy overall at Intel. And at its center, it says we're targeting markets, right? So we're targeting cloud and data center, and we have obviously some processor products that we target into that space, but we also have new products that we're introducing that expand our market reach, and those are focused around memory and FPGAs. And then we have a whole new market opportunity that we're pursuing around things and devices. This is the Internet of Things side of our market. And encasing all of those things is connectivity, and that's where Omni-Path comes into bear, right? So for the data center market, connectivity at Intel encompasses three product lines: Omni-Path, Ethernet, and our silicon photonics, right? So that just gives you a little bit of a picture of where Omni-Path fits in. Omni-Path itself is a very rich portfolio, a full fabric portfolio, right? So we have ASICs for both host and switches. We have HFI adapters that go in the compute nodes themselves. We have a full portfolio of switches, cables, and software. And then very importantly here, we bring these products to market, in some cases directly ourselves, but mainly through OEMs. So we have many OEMs that have purpose-built implementations of Omni-Path that meet their specific needs, right? For example, Penguin, HPE/SGI, Sugon, Huawei have all implemented purpose-built OPA infrastructure solutions within their own product families. Okay, not just taking the products that Intel produces, but actually building value-added products of their own. And then another key element of our portfolio is processor integration, right? So on the Knights product line, we've taken the step of implementing the client side of our solution directly onto a processor. And that's a key value proposition that you're going to hear from us going forward as well, because it's not something that can be easily matched by our competition, and it brings some obvious performance and price performance improvements. So one of the things that we often hear from our competition that I just want to refute right off the get-go here is that OPA is new and risky, right? So I think it's important that we understand that OPA is really an evolution of a series of technologies that Intel acquired, okay? Much of the software portfolio, for example, is in its fourth or fifth generation, right? So I'll come back to the software point, but I think it's important to understand that this new flavor of Omni-Path in the market isn't really a valid point, and the fact that we have a lot of experience in the market and we're building on an evolutionary path is one of the reasons why we've been able to ramp share as quickly as we can. So let's get on to the next slide and focus on performance. Okay, Rich, so high-performance computing, right? This is the target market opportunity where we're playing with OPA, and of course, performance is the key phrase, the key word in high-performance computing, right? So this is the number one criteria that customers tell us that they're buying on. And in this area, OPA is really delivering, right? So in the upper right-hand corner of the slide, you see a series of application benchmarks, and here we've normalized performance to 1 versus our primary competitor, Mellanox's EDR. Where you see the bars tipping above the dotted line for 1 there is where OPA is achieving superior performance to InfiniBand. So what this generally tells you is that across a broad spectrum of applications, we're at or better than InfiniBand. Okay, but I want to make a key point here that one of the things that we hear from our competitors is around scale. And here I think we have some very important things to say, right? So OPA was really designed with scale in mind. If you go all the way back to the beginning of what InfiniBand was built for, it was really built to be a general purpose data center interconnect. And in fact, storage is one of its primary drivers when the standard itself was created. And that's just not the same kind of messages, not the same flavor of communication that what we see in today's high-performance computing market. Omni-Path, while it was building on this stable ecosystem that I talked about, it really was built from the get-go with high-performance computing in mind, and that gives us some advantages, right? So our host architecture, coupled with our adaptive data management model, really allows us to deliver unmatched latency for performance-critical MPI messages, while at the same time allowing us to apply RDMA to larger messages, right? So we can maximize bandwidth at low CPU utilization. This flexibility is really a key asset for Omni-Path relative to our competitors. Two other points that I would hit here, right? One is traffic flow optimization. So we have features for quality of service that give the capability to have high priority packets get all the way through the fabric uninterrupted, as opposed to InfiniBand, where you have a sort of fairness model so that everybody's packets get through. What this allows application users and system administrators to do is really get the full line rate on OPA versus a fraction of the line rate that they might see on InfiniBand. We also have the end-to-end packet integrity protection, which deals with errors at the link level. This is, again, a significant differentiator for us versus InfiniBand. When we do take an error, and everybody takes errors, right? When we do take an error, we really only have to retransmit a FLIT, okay, a flow-controlled unit, which is 1,056 bits, okay, which is significantly less than resending from one end to the other the entire MPI message, which takes a lot longer and obviously drives down application performance. So we really did focus on performance and scalability at the get-go, which I think is a really important differentiator for us versus our competition. A couple of recent press releases would talk about application performance on InfiniBand versus OPA. I just want to set the record straight here, and we're going to have a whole separate podcast on this topic. But if you see in the upper right of this picture, GROMAX, we're significantly better, NAMD. So we really do have places where these architectural things that I talked about are giving us significant performance differentiation versus our competitors. Now let's talk a little bit about price performance, because this is also very key as a purchasing decision for our end customers. Here we have a significant advantage building largely on our port radix for our switches, right? So we have a 48 port radix versus Mellanox's 36 port radix. That allows us to have fewer switches. That's what the graph in the middle of the right side is talking about. That really gives us efficiency from a CapEx standpoint for end customers, right? We have fewer switches because of our larger port radix. We have fewer cables. What that allows customers to do is spend more on compute, which is, in the end, what they're trying to do. So this is a significant advantage for us relative to Mellanox, and one that we've definitely seen customers talk about when they take up OPA. So let's double-click one more slide on performance, and we'll get to another area about scalability. Rich, so I talked earlier about how Omni-Path has been designed for performance and performance at scale. So I just want to touch on one example here that I think is a nice proof point of what the message that I'm trying to get across here to end users. So you see at the top of this chart that this is a 4,096 node MPI collective benchmark. And in this case, we're measuring the time that it takes to perform the collective. So a lower number is better. And this is a nice story for us, right? Because remember when I told you that OPA was designed for scale, you don't see a lot of systems using InfiniBand at the 4,000 node scale. And why is that? And that's because InfiniBand wasn't really designed to be a scalable fabric from the get-go. It was a universal data center fabric. And it's just architecturally challenged for truly large machines. Omni-Path doesn't have that problem. So what's the story on this slide, right? So we're looking at two collective outcomes here for barrier and all reduce. And these are operations that are explicitly performed on all nodes involved in a job, and all at the same time. And collectives require a lot of communication between the nodes, right? So if you're not doing a good job on collectives, this could significantly slow down your application efficiency in a fabric if it doesn't scale, right? So the basic message here is very simple. When we first deployed this system at this customer, they were measuring collective scaling, and it was really excellent. The system went into production, as often happens in production environments. system administrators make changes, application end users make changes, and in this case, performance on the collectives deteriorated to the point where a customer was saying, hey, I'm not getting what I used to be getting, and maybe even worse, I'm not always getting the same result in terms of time to perform the collective. And that's really bad because in this case, the customer was trying to perform an entry for the Gordon Bell Prize, right? So they were explicitly working on scaling. They were making changes in the application, and they weren't seeing the same duration for their MPI collective operations. So they don't really know, was it the application changes they were making or was something wrong on the system? So they asked Intel to come in and have a look, and what we figured out was that through a series of changes that the end customer had made and Intel had made, we had introduced OS noise, right? So we all know the way Amdahl's law works, all right? If you have OS noise and you're performing a synchronous operation like a collective, you're very likely going to get random cases where you land on a particular node on top of that OS noise, which means you wait. And if you wait often enough, you find that your MPI collective performance goes down significantly. So once we understood this problem, we were able to make the changes both on the Intel software and to the OS configuration that got us back to the performance. And you see the significant reduction in terms of the time to perform the collective from the left side of the chart to the right side of the chart for both barrier and all reduced. So this is a really nice message, right? This tells us that we have an architecture that can scale, and it tells us that our post-sales support model for finding customer challenges is actually working and helping us to drive a good customer experience. So nice outcome at scale. Let's go on and talk about market momentum generally for OPA on the next slide. We really did come out of the gate nicely here is the chief message on this slide, right? So what we're talking about here is the impact on the November top 500 list of OPA. And I think just looking back in November, remember that Intel had been shipping at that point about 9 months, and our primary competitor here, EDR, had been almost 18 months in the market, right? So they really did have a nice head start on us, and what this slide shows you is that we very quickly overcame them and have charged out to a nice proof point in the top 500, right? So you see that in the pie chart, we're more than double the total number of systems in the top 500, and perhaps more significantly, we have more performance in the top 500. And then you have that application efficiency, and this is on LINPACK, right? So, maybe not representative of application efficiency generally, but still a very important proof point and one that customers pay attention to. And here again, we have an advantage on application efficiency with OPA for LINPACK as compared to Mellanox, right? So a couple systems that are definitely worth mentioning, right? So the Oak Forest PAC system in Japan, number 6 on the top 500. So again, showing that OPA can really reach up into the very, very high scales. We have a number of systems from the CTS, which is the U.S. Department of Energy capacity computing system that are in the range of 50 to 150. And we're starting to see some introductions of OPA outside of the pure academic research place, for example, with EDF in France through Bull and Atos, placing number 128 on the system. So really proud of the fact that we've gotten out of the gate here quickly, and we expect to be continuing that momentum as we come forward into the International Supercomputing Conference. Rich, let me tell you a little bit about Fabric Builders, which is a package that we've put together to really grow the ecosystem of OPA applications and end user partners. So what this is really a community of users that we expect to collaborate amongst each others to try to drive the growth and applicability of OPA within the broader marketplace. So you see that we've got bunches and bunches of logos here. We're more than 80 members now. And what we're really trying to do is share experiences across ISVs, across OEMs, and across resellers and distributors to really try to get a customer user base that will help to grow both the quality and usability of Omni-Path within the market. And we're really coming out of the gate here nicely. I'd also point out that we have started up an OPA users group meeting that meets regularly with direct end customers, where we're looking for that frank and open feedback from end customers on what we need to be doing better, what we're doing well, and where we ought to be going down the path in the future. And we hold that users group meeting a couple of times a year online and then face-to-face at the Supercomputing Conference here in the U.S. So, Rich, I hope I hope you've enjoyed this. I want to just give you one last point here, and that is that we're absolutely looking forward to seeing a lot of end customers and partners and users at the International Supercomputing Conference coming up here in the middle of June in Frankfurt, right? So, of course, we're going to have a very nice Intel booth, and Omni-Path will be prominently displayed in that booth, but also at many of our OEM partners will also have Omni-Path demonstrations in their booths. We're going to do a live Omni-Path webinar on the 20th of June. We'll also be doing a live podcast with you on site there, Rich, and really looking forward to seeing how we come out on the top 500 list relative to competitors, right? So this is a nice measuring stick for us as we progress through the year. So really excited to have joined Intel and to be leading the Omni-Path team, and looking forward to talking to you and other end customers in Germany in a couple weeks.
Well, great. Thanks, Scott, for that overview. It sounds like a great success so far. You've got the scalability, which was an important performance, and you're hitting price performance targets that customers are responding to. So I wanted to ask you about how this all works in lockstep with Intel processors. Um, where are we at in terms of what Xeons are you shipping today, and what's coming down the pipe that you can publicly tell me about?
So obviously today we are, for Omni-Path, we're shipping both the Xeon product line and the Knights product line, right? And we have the integrated, what we call the Dash F part, which embeds on a Knights processor, the Omni-Path HFI, right? So the client side of our solution. We are obviously talking publicly about where our roadmaps are going in the future, and the next generation of Xeon processor called Skylake is targeted to enter the marketplace at some point in this summer, and I can't get any more specific than that date. We're obviously very excited about the upcoming performance on Skylake and its tight integration with Omni-Path, right? So this is, as you would expect, part of Intel's tick-tock process, and we're really looking forward to Skylake being a significant bump in performance and our ability to integrate and deliver that performance with fabrics on Omni-Path.
Great, Scott, because I wanted to ask you a little bit about workloads, because you had some benchmarks there that show some typical HPC type of things. But what about machine learning and that kind of workload? Does OmniPath have a role to play there?
Sure. So AI is just exploding in the marketplace, and we're at Intel very excited about the prospects for next generation applications like AI and the implementation of those applications in new business models like cloud. Okay, so certainly Fabric has a role to play in AI, right? So early AI implementations were solving, I want to say easy problems, right? So in the high performance computing market, we often call those embarrassingly parallel problems, right? We're a little embarrassed by the fact how easy they are to implement in a scalable way by dividing the workload up across many nodes in a cluster, so to speak. I think as we move forward that those easy applications are a fraction of what AI will be used for. And as AI is asked to tackle harder or larger problems, scalability across the fabric will become more and more important to achieving efficiency, right? So I believe that fabrics like Omni-Path will provide an important capability to AI to allow AI to take on less embarrassingly parallel problems where more east-west traffic across the fabric will be critical to getting the application to scale effectively.
Well, Scott, I can't let you go away without asking, how did folks find you at ISC in Frankfurt? It's a big place.
Sure, Rich. So I guess the easiest way would be to come see us in our booth, right? So we're going to be at F930. You'll see the big Intel sign prominently displayed above the booth. So that's the easiest way to find us. Omni-Path is also going to be in many of our OEM partners' booths. We'll be doing some demos and obviously doing some talking at some of their booth events as well. So you'll see us in our OEM partners. We'll have a lot of customer face-to-face meetings, so end customers and partners were sure to hook up with us there. Also, I need to mention the fact that Raj Hazra is going to be doing an Intel HPC special keynote on Monday evening at 6 p.m. in the main show floor area. So look forward to hearing Raj talk about his vision for the high-performance computing marketplace and what Intel is going to be doing about that.
Well, great. Well, thanks, Scott, and I really appreciate you coming on the show today.
Absolutely, Rich. Look forward to seeing you in Frankfurt.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high performance computing.